According to National Electrical Code Section 250.24 FFB, grounding electrode conductors may be connected to the equipment grounding bus or terminal within the service equipment, such as the main service panel. National Electrical Code Section 250.24 states that grounding electrode conductors shall be connected to the equipment grounding bus or terminal within the premises wiring system. Section 250.24b states that any of the following shall be permitted. Firstly, connections shall be made in accordance with Section 250.12. Secondly, for service equipment rated 1000 amps or less, connections shall be permitted to be made by exothermic welding, listed pressure connectors, listed clamps or other listed means. And thirdly, for service equipment rated over 1000 amps, connections shall be made by exothermic welding or by listed bolted connectors or clamps. Moving on to National Electrical Code Section 250.12, which addresses connections. The requirements are as follows. 1. Connections shall be made in accordance with Section 110.14.2. Connections shall be accessible except as provided in 110.26e3. Wires from different circuits, including grounding wires, shall be permitted to enter or leave the same raceway or enclosure through a common opening, but shall be separated by a barrier or other equivalent means to prevent contact. 4. Box and conduit bodies equipped with clamping means for securing the conductor or raceway shall be used for splices, taps and terminals where required. 5. Splices and taps shall not be made in pull or junction boxes unless the boxes are accessible. 6. Terminals for more than one conductor shall be of a type approved for the number of conductors. 7. Conductors of different systems, alternating current and direct current, shall not be terminated in the same terminal. 8. Splices shall be accessible after installation. 9. Splices or taps shall be made with approved splices. Conductors and splices shall be protected against mechanical damage. And 10. Insulation, isolation or grounding shall be provided for conductors from different systems, alternating current and direct current, where terminated in adjacent terminals. This means that while terminating the grounding electrode conductor at the main service panel is common, the National Electrical Code provides options for connecting it elsewhere, including potentially at the meter base, provided that all applicable requirements are met. When considering terminating at the meter base, there are several crucial points to consider. Firstly, ensure that the meter base is listed and labeled for use as service equipment, meaning it is designed and approved for that purpose. Not all meter bases are suitable for service equipment applications, so check the product listings carefully. Secondly, verify that the meter base has a designated and properly sized equipment grounding bus or terminal. This bus or terminal must be adequately rated to handle the fault current and size appropriately for the grounding electrode conductor. Thirdly, the connection method must comply with National Electrical Code Section 250.12 and 250.24b. For service equipment rated 1000 amps or less, you can use exothermic welding, listed pressure connectors, or listed clamps. For equipment over 1000 amps, exothermic welding or listed bolted connectors or clamps are required. The connection must be secure and provide a reliable, low impedance path to ground. Fourthly, accessibility is a key requirement. National Electrical Code Section 250.12 states that connections must be accessible, meaning they can be readily reached for inspection, maintenance, or testing without requiring significant disassembly or demolition of the building structure or finish. While exceptions exist under 110.26e, they are specific to equipment, not connections. Fifthly, conductor sizing is vital. The grounding electrode conductor must be sized according to National Electrical Code Table 250.66, based on the size of the service entrance conductors. Using an undersized grounding electrode conductor can compromise the effectiveness of the grounding system and pose a safety hazard. Sixthly, protection from physical damage is crucial. The grounding electrode conductor must be protected from physical damage, as required by National Electrical Code Section 250.64b. If the conductor is exposed to physical damage, it must be installed in rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, electrical metallic tubing, or cable armor. Seventhly, bonding requirements must be followed. All metal enclosures containing service conductors, including the meter base, must be properly bonded to the grounding electrode system as required by National Electrical Code Section 250.92. This ensures that all metal parts are at the same electrical potential, minimizing the risk of shock. 8. Local amendments and utility requirements must be considered. Local jurisdictions may have amendments to the National Electrical Code, and the local utility company may have specific requirements for grounding at the meter base. Always check with the local authorities to ensure compliance with all applicable regulations. 9. Documentation and labeling are essential. Clearly label the grounding electrode conductor termination point and document the installation in the electrical panel schedule. This will help ensure that future electricians understand the grounding system and can maintain it properly. 10. Inspection is important. After completing the installation, have it inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and standards. This will help identify any potential problems and ensure that the grounding system is safe and effective. In summary, terminating the grounding electrode conductor at the meter base is permissible under the National Electrical Code, provided that the meter base is suitable for use as service equipment, it has a designated equipment grounding bus or terminal, the connection method complies with National Electrical Code Section 250.12 and 250.24b, the connection is accessible, the grounding electrode conductor is properly sized and protected from physical damage, all metal enclosures are properly bonded, local amendments and utility requirements are followed, the installation is documented and labeled, and the installation is inspected by a qualified electrical inspector. By carefully considering these factors, you can ensure that the grounding system is safe, effective, and compliant with all applicable codes and standards. Remember that proper grounding is essential for electrical safety, protecting people and equipment from shock and fire hazards. If you are unsure about any aspect of the grounding installation, consult with a qualified electrician.